All right, in this video, we are going to be catching up on scientific notation. I'm going to make some assumptions about some of the exponential properties, and if those assumptions are unclear to you, then you need to go back and watch the video on exponents. When we are talking about scientific notation, we're talking about an easier way to represent the place value of big and small numbers. So, for example, if I said, what is 3, what is 3, comma 0, 0, 0, comma 0, 0, 0, comma 0, 0, 0. Instead of having to count this, and especially if you're working with a lot of numbers, each time having to count all these zeros, we can express this number in scientific notation. And scientific notation basically says, hey, what's the most important number here? What's the most significant digit? And in this case, it's pretty easy. It's the 3. So my coefficient becomes the most significant digit, and I say, what place value is it in? Well, we have to remember about exponential properties. The ones place is 10 to the 0, because any number to the 0 power is 1. And then 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 5, 6, 7, 8, 9. That 3 is in the 10 to the 9th place. And this 10 to the 9 just means 10 times itself 9 times. And since place value is based on multiples of 10, or powers of 10, then this 3 is in the 10 to the 9th place. We can also work with small numbers in the same way. If I want to represent the number 0.0000000003, I say, okay, this is 10 to the negative 1. Because if this is 10 to the 0, and this is 1 less than that, well, 1 less than 0 is negative 1. Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So the most significant digit is still 3 because everything else is 0. But it's in the 10 to the negative 10's place. 10 in the negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. This 3 is in the negative 10's place value. Now, if that number has more than one digit that's not 0, let's say 4, 6, 5, 0, 0, 0, 0, 0, 0, right? Well, the most significant digit is still the one furthest to the left. It's 4. So that's what we want to know the place value of. The most significant digit always has to go in the ones place. And the example that I used in class was if you had, kind of sidebarring over here, if you had $3,000, you wouldn't say, I have 30 hundreds, because that's hard to understand. You didn't have to figure out, well, what is 30 hundreds? Well, 30 hundreds would really be 3,000s. It's much easier to use a place value in the ones place and say 3, and then this is in the thousands place, so you would say 3,000. So in scientific notation, we want the most significant digit to be in the ones place because that's the easiest to understand. But we can't ignore the fact that this 6,5 is to the right of it. Well, if this is the ones place, then to the right of it is the 10ths place, and to the right of that's the 100ths place. So now we've kind of represented these important numbers. We need to figure out, well, what place value is the most significant digit in? Well, the ones place is 10 to the 0. 1, 2, 3, 4, 5, 6, 7, 8. That's in the 10 to the 8th place. So this number put in scientific notation would look like this. If we were talking about a very small number, then once again, the most significant digit is the one furthest to the left. So that's the 7, because the zeros don't count, right? No matter what place value a 0 is in, it still just represents 0. So there's a 7 in the ones place, because the most significant digit goes in the ones place, but there's this 9, 2 to the right of it. Well, now what place value is the most significant digit in? Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. This is the 10 to the negative 7th place. Because if the ones place, which would be right here, is 10 to the 0, then to the 1 less than that is negative 1, and then we count all the way out to 10 to the negative 7. With that said, we need to be able to do some calculations in scientific notation. We need to be able to say, hey, okay, let's see here. If I say 4.23 times 10 to the 3rd, that's one number in scientific notation. And I want to multiply it by 2.6 times 10 to the 4th. It's another number in scientific notation. Well, I have to do two things. I first of all need to use my associative property and my commutative property to get rid of these parentheses and rearrange so that my coefficients are being multiplied together. All right, so I just did that and that. And that's being multiplied by terms, or my place value representations. Well, this becomes easier to solve. What is 4.23 times 2.6? I say, okay, that's 8,131. That's 24, 25, so 5, 2. And 2, I got to put a placeholder there. And in the multiplication videos, we talk about why there's a placeholder, but I'm going to kind of skip over that. And if you're not sure, go back and watch that. So 6, 4, 8, right? 2 times 3 is 6, 2 times 2 is 4, 2 times 4 is 8. And now I add this together and I get, let's see here, 89901. And now there is 1, 2, 3 digits to the right of the decimal. So my decimal needs to go here. So now this becomes 10.998 times, this is 3 tens and this is 4 tens, so that's a total of 7 tens. Now I have a new problem. My most significant digit is in the tens place, not the ones place. So I'm going to divide this by 10. I'm going to take a 10 out of this, and I'm going to get 1.0998. Well, in order to keep this equal, if I took a 10 out of here, using the associative property, I need to move it over here. So I have one more 10 now. And that would be that number in scientific notation. That's an 8. The same concept applies for division. If I said what is, I don't know, 5.6 times, really? 5.6 times 10 to the third divided by 2 times 10 to the first. Knowing that fractions and division are the same thing, this gets rewritten as 5.6 times 10 to the third divided by, or over, 2 times 10 to the first. And knowing that using our multiplication algorithm, we can kind of undo this and say, hey, that would be the same thing as if I had 5.6 over 2 times 10 to the third over 10 to the 1. Right? Because if I had to multiply these, I would just multiply across, which is what I'm doing here. And I say, well, what is 5.6 divided by 2? And I'd say, well, I don't know. 2 goes into 5 2 times, and 2 goes into 16 8 times, so this must be 2.8 times. And when I'm dividing numbers with like bases with exponents, I just subtract these, right? Because this one down here cancels out one of them up here, so I'm left with 10 squared. And my most significant digit happens to be in the ones place, so this is the final answer. These are the concepts you need to know to be successful on the scientific notation test. If you're still unclear, go to Khan Academy, watch some more videos, and of course, practice those modules. Thank you so much.